Okie dokie. Properties of electric fields. I've already slipped into making comparisons between them, electric fields and gravitational fields. It's almost as if everywhere we substitute, we said the word mass. I'm talking about gravitational fields. We could insert the word charge, and it would be true for electric fields. They both produce radial fields for point masses and point charges. They both provide a force which is inversely proportional to the square of the separation, the distance from whatever the source is. The key difference is that gravity is always attractive. As far as we know, there's no such thing as sort of negative gravity, repulsive gravitational force, while the electrostatic force can be either. There's also this curious difference that electrostatic forces can be shielded, but gravity cannot be. There's a device called a Faraday cage, named after Michael Faraday. It's essentially just a metal box. But it is possible to block electrostatic forces, whereas as far as we know, we don't have an equivalent for gravity. You can put yourself in a metal box, but you'll still have weight. We've yet to develop an anti-gravity machine, which is sad in its own way, but we live and we learn. Right, let's do this exam question, talk a bit about electric potential, and then we'll be ready for our next break. Good, we're okay for time. Okay, charged particles are directed from radioactive isotopes through a detector consisting of two parallel oppositely charged plates. Lovely, we'd love to hear it. When a particle collides with the plate, it can be detected as a change in voltmeter reading as its charge is added to the plate. Yeah, that makes sense. So if an electron, crashed into the positive plate, the potential difference across it would be slightly less. Describe and explain the path of a proton and an electron entering the detector at the same time and traveling at the same initial horizontal speed parallel to the plates, and discuss how the detector will be able to distinguish between them. 5 marks. Oh, brutal. Okie dokie. It is worth drawing yourself a little diagram. This question isn't necessarily assessed by a diagram, but I think it's useful. So we're asked essentially to compare an electron and a proton. Their charge has the same magnitude, but they otherwise have different masses. With the mass of the proton being quite a lot larger. And they've got opposite sign charges. So the electron will be repulsed by the negative side, attracted to the positive. The electron is going to, the electron will curve down, and the proton will curve up. The only thing then to decide is there going to be any further difference in the trajectory? And the answer is yes. The proton is going to curve far slower because it has more mass. Its inertia is larger. And they start with the same velocity. The electron and proton have equal and opposite charges, so will experience equal and opposite vertical forces traveling between plates. Nice physics fact. They've got equal and opposite charges, so they'll have equal and opposite forces. Each particle is attracted to the oppositely charged plates, and the charge on this plate is reduced when the electron-proton collides with it. Yep. The change in the charge plate is equal for both particles, which causes some fluctuation in the voltmeter reading. Yeah. However, this is where so we can definitely detect when one or the other arrives. What we can look at is that the proton has much higher mass than the electron. So they've both got the same force acting on them. So the force on the proton and the force on the electron. These are equal, but that does not imply, it does not imply that the masses are equal or the acceleration is equal. It implies this is true. Okay, so the ratio between you could say the ratio between their masses is going to be the ratio between their accelerations, or inverse relationship between their accelerations. The proton is about 1,000 times more massive, so it's going to have an acceleration about 1,000 times slower. Therefore, the electron collides with the detector plate first, and the proton collides with the plate second. Yeah, hopefully that stands to reason. I've done a little bit of maths on the side of my question. It can't hurt to have it there.